Good day, everyone, especially to our professor, Mr. Jake Pomperada, and to my classmates as well. So, my topic for today is about software matrix in software engineering. So, without further ado, let's get going. So, in this topic, we will discuss the five points about software matrix. First is the introduction, second is the brief history, third is the importance of software matrix in software engineering. Fourth is the applications of software matrix in software development. And last is the conclusion. Introduction in software matrix. A software matrix is a tool used in software engineering to visualize and analyze relationships between software components. It displays dependencies between different modules or components of a software system. So, a software matrix is a tool used in software engineering. So it will visualize and analyze relationships between software components. When we say software components in software engineering, there are 15 points. But I will just give five major points or five major list of software components. But below on the slide, we have 15 software components. So, for example, we have we have operating system, database management system, web server, application server, and frameworks. So this one has dependencies between different modules or components of a software system. So when we say dependencies, it will rely on each other, on each components in software engineering. So for example, operating system will rely on database management system, and database management system relies on web server. Application server relies on framework, or vice versa. So it helps identify potential problems and areas of improvement in software design, especially in large projects with many components and dependencies. So developers can use it to understand the system's complexity and make informed decisions about improving it. So for example, let's say that a software development company is working on a large project that involves multiple components and dependencies. So they decide to use a software matrix to help them better understand the relationships between these components and identify any potential problems or areas of improvement. Using this matrix, they can see that for example, component A is dependent on component B and component C, while component D is dependent on component A and component E. So on the later part, I will just give an example about the software matrix and the dependencies. So this information will help the developer to understand the complexity of the system and make informed decisions about on how to improve it. So let's consider a common example. RTM, or a requirements traceability matrix. So this is an example of applications of software matrix in software engineering. So RTM, so this matrix is used to establish and maintain relationship between requirements and other artifacts such as design documents, test cases, and code changes. So here's how it works. So in this example, on our right side, we have a table named example of simplified RTM. So in the first row, we have on the first row, on the on the top row, we have the requirement, the design, the code, and the test. So in each column, we have different requirements or names. Example, RAQ Rec 1, design D1, code C1, and test T1. So in this example, so for example, request 1 is associated with design D1, code C1, and test C1. So next example is rec 2 is associated with design 2, code C2, and test 2. Last is rec 3 is associated with design D3, code C3, and test T3. So in this example, it will show that this matrix provides a clear overview of how requirements are linked to various development and testing activities. So if there's a change in, let's say, code C2, you can easily see that it impacts requirements rec 2 and test T2. So this is an example of dependencies in software matrix. So in summary, software matrices like requirements traceability matrix or RTM are essential tools for managing complexity, ensuring consistency, and facilitating effective communication across different stages of software development. Brief history of software matrix. The concept of using matrices in software engineering traces back to the early days of the field. However, the systematic application of matrices gained prominence as software development methodologies evolved and became more structured. Here's a brief history. 1970s and 1980s emergence of structured development methods. During this period, structured methodologies such as structured analysis and design technique SADT and structured systems analysis and design method SSADM emerge. These methodologies emphasize the importance of systematic analysis and documentation in software development. Matrices were used in these methodologies to represent relationships between different elements of the software, such as data flows, processes, and entities. Next, 1980s to 1990s, quality management and process improvement. With a growing emphasis on quality management and process improvement, matrices became integral to software engineering practices. Quality management frameworks like Capability Maturity Model (CMM) highlighted the importance of metrics and measurement in assessing and improving software processes. Matrices were used to track and analyze metrics related to process performance and quality. So in this year, they are more focused on quality management and process improvement. So matrices have played a critical role in software engineering practices. So particularly with the growing emphasis on quality management and process improvement. Quality management frameworks like CMM relied on matrices to track and analyze metrics related to performance and quality. So, enabling software engineers to identify areas of improvement and implement more effective practices. Next is 1990s 2000s. Rise of software matrix and metrics-based process improvement. The adoption of software metrics became widespread during this period. Matrices were used to represent various software metrics such as lines of codes, defects, and code complexity. Metrics-based process improvement frameworks such as Software Engineering Institute's SEI, CMMI emphasize the use of quantitative data and analysis for process improvement. Matrices played a crucial role in capturing and visualizing this data. So during this period, the adoption of software metrics became widespread. So, with matrices being used to represent various metrics such as lines of code, defects, and code complexity. So, this shifts towards metric based process improvement was further emphasized by frameworks like SEI's CMMI, which relied on quantitative data. So when we say quantitative data, it is a numerical data that can be measured and expressed in terms of quantity or amount. So matrices played a crucial role in capturing and visualizing this data. So this will allow software engineers to identify areas for improvement and implement more effective software development practices. 2000s and present. Agile and iterative development practices. With the advent of agile and iterative development practices, the focus shifted towards flexible and adaptive processes. Matrices continued to be used in agile contexts, although in a more lightweight and flexible manner. For example, agile teams use burn down charts and velocity charts to track progress and plan iterations. So during this period until present, so the main goal or the main focus now is to use agile and iterative development practices. So when we say agile is it is an iterative approach to software development that emphasizes flexibility, collaboration, and customer satisfaction. So when we say iterative, it is a repetition, repetitus, or making repetition relating to or nothing, or a development strategy that involves a cyclical process or of refining or tweaking the latest version or iteration of a product. So agile is an iterative approach to software development that emphasizes flexibility, collaboration, and customer satisfaction. So it involves breaking down a project into smaller, manageable pieces called iterations or sprints. So it continuously delivers working software to the customer at the end of each iteration. So agile development is based on Agile Manifesto, a set of values and principles that prioritize individuals and interactions. So, working software, customer collaboration, and responding to change over following a rigid plan. So, the goal of agile development is to deliver high quality software that meets customer needs in a timely manner and cost effective. So, throughout this history, the use of matrices in software engineering has evolved from representing structural and process related information to facilitating data driven decision making and process improvement. So, today, matrices remain an essential tool in software development, enabling teams to track and manage various aspects of the software life cycle effectively. So the next topic is about the importance of software matrix in software engineering. So software matrix is an important tool in software engineering for several reasons. Importance of software matrix in software engineering. So first is visualizing software complexity. So software systems can be complex and difficult to understand, especially as they grow in size and scope. So software matrix provides a visual representation of the relationships between different components, making it easier for developers to understand the system structures and complexity. So it gives you an image or a picture of how relationships of different components. So this will give software developers an easy understanding of software structures of a project. Next is identifying potential problems. So by analyzing the dependencies between software components, software matrix can help developers identify potential problems before they occur. So this can save time and resources by allowing developers to address issues early in the development process. So to scrutinize the reliance between the software components, so it will help building a specific project or a specific software that helps to potentially look all the problems all the problems inside or during or after the project has been finished or completed. So in this way, the company can save time and also the resources. So this will have a significant impact on a software development stage. Next is improving software design. Software matrix can be used to improve the overall design of software systems. So by identifying areas of high coupling or low cohesion. So developers can make informed decisions about how to improve the system's architecture and design. So when we say high coupling and low cohesions, these are two related concepts in software engineering. So it describes the quality of the design of a software system. So high coupling refers to the degree to which different components of a software system depend on each other. So when components are highly coupled, changes made to one component can have a significant impact on other components, making the system more difficult to maintain and modify. While low cohesion, on the other hand, refers to the degree to which the elements within a single component are related to each other. When a component has a low cohesion, it may perform multiple unrelated functions, making it more difficult to understand and modify. Next is managing software dependencies. So, software matrix can help developers manage dependencies between different components of a software system. By understanding the dependencies between components, developers can make informed decisions about how to organize and structure the system. So last is enhancing software quality. So by improving software design and managing dependencies, software matrix can help enhance overall quality of a software system. This can lead to more reliable and maintainable software that meets the needs of the user and stakeholders. Next topic is about the applications of software matrix in software development. Software matrices are important tools in software development that helps in measuring, analyzing, and improving software quality. They are used to track and measure various aspects of the software development process, such as code coverage, defect density, complexity, test case execution, and requirements traceability. The following are some brief applications of software matrices in software development. Brief applications of software matrices in software development. First is code coverage matrix. This matrix is used to measure the percentage of code that is executed during testing. It helps in identifying untested code and improving the test coverage. So, for example, if the code coverage matrix shows that only 80% of the code has been executed during testing, developers can focus on writing additional test cases to improve the coverage. Next is a defect density matrix. This matrix is used to measure the number of defects per unit of code. It helps in identifying the areas of code that are prone to defects and improving the quality of the code. So, for example, if the defect density matrix shows that a particular module has a high number of defects, developers can focus on fixing those defects and improving the quality of the codes. Cyclomatic complexity matrix. This matrix is used to measure the complexity of the code. It helps in identifying the areas of the code that are complex and difficult to maintain. So, for example, if the cyclomatic complexity matrix shows that a particular function that has a high complexity score, developers can refactor the code to simplify it and make it easier to maintain. Next is a test case execution matrix. So this matrix is used to track the execution of test cases. It helps in identifying the test cases that have been executed and the ones that are pending. So for example, if the test case execution matrix shows that a particular test case has not been executed, developers can run that test case to ensure that all tests have been run. Last is the requirements traceability matrix. This matrix is used to track the requirements of the software in their implementation. It helps in ensuring that all the requirements have been implemented and tested. For example, if the requirements traceability matrix shows that a particular requirement has not been implemented, developers can work on implementing that requirement and testing it. So overall, software matrices are important tools that help in improving the quality of the software and ensuring that it meets the requirements of the stakeholders. By using the software matrices to track and measure various aspects of the software development process, developers can identify the areas that need improvement and take steps to improve the quality of the software. So, in conclusion, software matrices are important tools in software engineering that help in measuring, analyzing, and improving software quality. They provide valuable insight into the software development process and help developers identify areas that need improvement. By tracking metrics such as code coverage, defect density, complexity, test case execution, and requirements traceability, developers can take steps to improve the quality of their software and ensure that it meets the requirements of stakeholders. Software matrices are essential for ensuring that software is of high quality, meets the needs of the users, and is delivered on time and within the budget. As such, they are an indispensable part of the software development process and are widely used in software engineering today. So, for a recap, I have discussed the introduction, brief history of software matrix, and the importance and applications of software matrix in software engineering and in software development. I hope that's been informative for you, and I'd like to thank you for viewing.